Hi guys, today we're Math 8 and we're looking at day 7. I have to put this because when they upload they don't show me which recording it is, so I try and keep my sanity by remembering what day we're on. So day 7 we are looking at lesson 44 and 45 today. So you can go ahead and flip there in your book. This is on page 321. So lesson 44, solving proportions using cross products and looking at slopes. Okay, so two different concepts we're looking at today. Okay, so a cross product, okay, when we do in cross multiplication or a cross product, these, if the fractions are equal, then the cross products have to be equal or else they're not. So let's show an example where it's not. So I know 1/2 is not equal to 1/3, but we could also prove that it's not by doing a cross product. 1 times 3 is 3, 2 times 1 is 2. Well, 3 does not equal 2, so these fractions don't equal. But we could do 1/2 equals 5/10. Okay, 5 over 10 reduced down to 1/2, but let's use a cross product to check our work. 1 times 10 is 10, 5 times 2 is 10. 10 does equal 10, so we know these fractions equal each other. So that's what it means when it refers to a cross product. Okay, and we can use that when we have unknowns. So if we're told they're equal, m over 10 equals 15 over 25, I believe that was the fraction. Yeah, 15 over 25. So we can use what we know about cross products to cross multiply and divide. So cross multiply and divide, cross multiply and divide. You guys will get very good at this and you'll get sick of hearing me say it, but we cross multiply. If we have an unknown in the numerator or the denominator, we have to cross multiply. So I get 25 times m equals 10 times 15, which is 150. Then we divide. So 25 over 25 is just 1, so that's how we cancel out. And then 150 divided by 25, what is that? 6. So m equals 6. Okay. And then we can put it back in and reduce both of them down to, reduce fraction and prove that they're equal. 6 and 10 reduces down to 3/5. 15 over 25 reduces down to 3/5 as well. A slope is maybe a new concept. If we have a line or something, you've probably been driving on the interstate or a road somewhere and you've seen a little sign with a truck moving downhill and it gives you a number. That's referring to the slope. Obviously, the steeper the slope, the faster you're going to go. So if you're driving a truck or hauling something, you want to be aware of that. Or riding a bike or whatever, or going uphill, then you want to be aware of it as well. But how we calculate slope is the rise over the run, or rise divided by run. So that's how we get our slope. Rise obviously refers to the vertical movement. The run refers to the horizontal movement. Okay. So rise over run, okay, or we can obviously have slope that's going down. We drop as we're moving to the right. We go up as we're moving to the right. We're going to have a positive slope. So over here we would have an example of a positive slope. Over here we're going to have the example of a negative slope. Okay, so if we have a rise of 2, run of 4, 2 over 4 is 1/2. If we have a rise of 4, run of 2, 4 over 2 is 2. So the higher this number is, the steeper the slope. Okay, if we're riding a bike uphill, we'd much rather have a slope of 1/2 than a slope of 2. This is straight up and down. We probably would have to climb up this with climbing gear. We wouldn't be able to ride a bike up it. Okay, if we have a negative number, obviously rise of -3, run of 2, -3 divided by 2, okay, -3 halves. Okay, if it's horizontal, we have no rise and a run of whatever. It's still 0 divided by anything is 0. Now, you may be asking, well, what if it's vertical up and down? Well, if it's vertical up and down, it won't pass the vertical line test. And let's say we have a rise of 10 and a run of 0. Well, 10 divided by 0 is undefined. It's infinity. We can't divide by 0. So 10 divided by 0 would not work out. So if we have anything that's a vertical line, it has no slope because it's not a function. Okay, if we look at example 2, Derek drives the highway at a steady rate, noting that time and distance he has traveled. The graph describes the distance Derek travels when driving at a constant rate of 50 miles per hour. Find the average rate of change in miles per hour Derek drives over these 3 intervals: 0, 1, 1 hour, 3 hours, 3 hours, and 4 hours. So we take a look. A rise of 100. He's gone from 50 miles over 1 hour. So 50 miles per hour. Okay, we go from 1 to 3. So that's a run of 2. And we've gone up by 100. 100 divided by 2 is 50. Then we go another hour over. And we go up 50. So rise of 50 divided by 1. 50 over 1 is 50. So he's going at a constant rate. So it doesn't matter if we have a line. It doesn't matter which point you pick. Okay, because if it's a linear function, it's going to be the same slope no matter where we look at the function. So it doesn't matter which 2 points you pick, you just do rise over run. If it goes through the origin, that's an easy place to start, because then we can just count up and over or whatever the line is doing and figure out the slope. Okay. A practice set, we will go over that when we return. Lesson 45, ratio problems involving totals. Okay, so some ratio problems were, boys to girls in the class. Well, we can say boys to girls, and then pretty easily, if we have 10 boys and 8 girls, well, we can pretty easily figure out the total number of students. We would have 18 total students in the classroom. So when we're given a ratio, we can usually find the total pretty easily. Okay. Let's look at this example. So we have acrobats and clowns converged on the center ring in the ratio of 3 to 5. So 3 comes first, so that's referring to acrobats. Clowns refers to the 5. So 3 to 5, we can write that as a fraction. We can also write it into what's known as a ratio box. So we have acrobats, clowns, total 3 to 5. We would add those up, 7. So this would be our ratio. And then what we usually call over here, it's hard to write on this thing, is our actual count. So 3 to 5. What am I doing? Hold on. You guys are at home screaming at me and I can't even hear. 3 to 5 gives us a total of 8. So we just add up the 2 we're comparing and we get 8. And then this would be our actual count. And that was, if a total of 24 acrobats and clowns performed in the center ring, how many clowns were there? So 24 acrobats, and we want to know how many clowns performed. So once we find this number, we could easily find the total number of performers, acrobats plus clowns, but we don't need that right now. So what we're going to do is we're going to set up equivalent fractions. Since a ratio can be written as a fraction, we'll call it 3 to 5 equals 24 to C. So make sure your acrobats are in the same row, and then your clowns are in the same row between your ratio and your actual, and we just set it up. Then what we just learned, cross multiplication and division, we're going to do 24 times 5, was that 120? Then we divide by 3. 3 goes into 12, 4, so that's going to be 40. So our number of clowns was 40. That was our total number of clowns based on the ratio we were given. Okay, so we just set up what we know, ratios, put them in equivalent fractions, and then we cross multiply and divide. Okay, see, I read the problem wrong. What does it say? Oh, okay, it's 24 acrobats and clowns. So see, make sure you put it in correctly. We did the math correctly, it's just we read the problem incorrectly. So 3 to 5 to 8, there's 24 total number of performers. Okay, so we do 5 to 8 equals C over 24, cross multiply and divide, and we get 15. And so I read it as 24 acrobats, not 24 total performers. So again, my fault, but that's where you get in a hurry and you don't read the problem. Go back and check your work. Okay, a bus company has small, large buses in a ratio of 2 to 7. If they have 84 large buses, okay, how many buses does it have? So 2 to 7. And then where does the 9 come from? Well, we add those two together. 2 plus 7 is 9. So that's where we get our total. Down here, we're given the amount of large buses, the actual count. So we put that here. Okay, and then we have small buses and total. And what do we want to know? Do we want to know small buses or total? Okay, we want to know the total. So let's set up 7 over 9 equals 84 over t. We cross multiply and then divide. So 9 times 84. Then we divide that by 7. And that gives us 108. Okay, so we have 108 total buses. If you ever get a weird number that seems way too big or way too small, or in this example, we can't have a third of a bus or something like that. So if you get something weird, go back, check your work, make sure you did it correctly. Okay, and then the practice set problems we'll go over when we return in class. So that's lesson 44 and 45 for you. All right, we'll see you guys in class.